it's important that the models are reproducible, and it checks off from the reproducibility standpoint from the model which has been given by the developer of the model. Right?
I see.
And
Okay.
then it's also important that the functionality is also present.
So let's talk a little bit more about machine learning now. What is your technical stack for the machine learning models that you build at One Concern?
Sure, yeah. I think the way how we really think about it is we have different tech stack, I would say, for every step along the way in terms of our model pipeline as well. Let me just start with the data processing pipeline in itself. We gather our data sets from multitudes of sources, of course, starting from public data sources based on the permission and which are allowed on the data sets. Then it's about using the vendor data sets. We work with various vendors. And the last step over here is also on developing synthetic data sets. In regards to the synthetic data sets, it's developed using models. So I'll go into that later. But the data sets themselves, we use GCS buckets to store our data sets. These are all versioned. Each of these buckets are versioned, and then we semantically version them and then make sure that it's all accessed in a clear way through semantic version amongst team. And we document them from the development standpoint and then also at the production standpoint as well. Now, we use Argo pipelines for the pre-processing step. Now, once that is done, let me go into the model development standpoint. We use, of course, notebooks as any other data science team would.
Yep.
We also have Jupyter Hub, which is running on Google Kubernetes GKE. And then we, at the same time, we actually use other set of tools.
So you're a Google shop.
Yes,
Everything's
we
running on
utilize
Google.
GCP a lot. And then once the models are developed, these semantically versioned model versions are now being uploaded on model artifact storage.
Okay.
Yeah, and that's as a part of a package now. So the model deployers now only have to deploy that one single Python package. Now, which has access to any of the models which have been developed by the model developers. And this improves the velocity of the teams now. Okay. Now, when you go into the model deployment, that's where Argo pipeline comes in over here, where depending on which version of data you're going to generate, you will utilize a package which has different combinations of various model versions.
I see. Okay.
And that's basically the packaged pipeline. And then the Argo pipelines are being run. We use Snowflake to generate data sets. And so we use Snowflake to store the data sets. We use Argo pipelines to run our model pipelines. And once the data sets are generated, it's also important for us to make sure the quality of data sets are also good. That's where we use great expectations, where we set expectations on the data sources.
And so what type of expectations do you say? Like in terms of distribution of data, things like that? Okay.
On any other outputs as well. And at the last step, we also generate reports on the distribution of the data, the spatial
And so the input,
distribution.
I see. So the reports are useful both for development, but also maybe for customer education or sharing some of that stuff as well.
To make sure that the quality of data is good, and it
Right. To make sure the models are good. Yeah.
Exactly. The models are. It's important that the models are reproducible, and it checks off from the reproducibility standpoint from the model which has been given by the developer of the model.
Right? I see. Okay.
And then it's also important that the functionality is also present, right? This right set of outputs are being generated as well. So of course we have CI/CD where we use Circle CI for the models, which uses a few set of tests to make sure the models are functionally working. Then also the reproducibility is being taken care of over here for CI/CD. Then once it's actually being run, that's where we use great expectations to make sure that the data quality is meeting the basic minimum standards. Once the basic minimum standards are being met, that's when we generate the reports.
So do you ever run into challenges where the distribution is not what you expect, or maybe not, that means now you have to find more data or you need to,
Exactly. So when we use great expectations in a way, we know which specific regions there are bugs really coming up.
Mm.
So we dive deeper into it without requirement of actually a data scientist really performing the quality check manually.
So there's a data team that works on that, and then
So the modeling team
I
and the
see.
engineering team work together for this one, ML
Hmm.
engineers. But we basically make sure that we have automated tests to identify where the bugs are.
Got it.
Okay,
Okay.
and then
Hmm.
the data scientists and the ML engineers work together to identify why that has happened, and then
Hmm.
we rerun the pipelines to make sure it's accurate there. So again, this is all for
Hmm.
running the jobs in an offline manner because we
Hmm.
generate a huge amount of data upfront so that
Hmm.
we can serve that and provide those to our clients.
Hmm.
So that's the first step on great expectations, and followed by reports. The reports are also evaluated to
Hmm.
make sure it checks with
Evaluated by
the
subject
data
matter experts
scientists,
or
the
by
subject
data
matter,
scientists.
yes,
Okay.
and then make
Hmm.
sure that it meets all the necessary criteria,
Hmm.
and we discuss if there is any weird behavior,
Hmm.
and if there is no resolution required,
Hmm.
then we move ahead.
I
Now we
see. I
have the
see. Okay.
new data sets which are being created with that's on Snowflake,
Hmm.
and then
Okay.
this data is now shared with our clients
Hmm.
using APIs. And the challenge with, or the limitation of Snowflake is that it's an analytical
Hmm.
database. So you still have to use it along with the transactional database as well.
Hmm.
That's why we
So
use a
you do have to
copy of that.
do. So do you have to do usually like a dump of the transactional
Yeah, so
database
we
to
need
the
to take a
Snowflake at
subset
some
of
point?
the Snowflake
Okay.
tables
Hmm.
and use that in transactional database like Postgres.
Oh, the other way around. So it's not just that the
So we
Postgres database goes into the Snowflake, but it's also that some of the data
no, we
from
don't use Postgres to Snowflake. We have pipelines which are generating the data and then storing that directly into
directly in
Snowflake.
Snowflake, and then that gets put into Postgres for later
Exactly.
archival
For
or for.
APIs to use it.
Ah, okay, okay, okay.
So
I
that
see, I see. So
APIs can now
Snowflake is just really useful for
generating and
manipulation
manipulating
and manipulating. Okay,
analytical data sets.
got it. Okay.
Right? And then these can have like terabytes
Hmm.
of data,
Hmm.
but there are limitations on what Postgres is really good for as well.
Hmm.
So we
Yeah,
use the best of both kind of databases.
I see. I see. Okay. Okay. Cool. Okay. So I see. So basically, we talked through the data piece. We talked through a little bit of the modeling piece. Maybe can
I'll
you?
actually talk more about the model in itself, actually.
Yeah, because I was thinking we could go
Yeah,
through maybe some of the models that you
yeah,
build at One Concern and how they solve some of the problems for the
sure, yeah.
customers.
With respect to the models itself, we start with semi-supervised
Hmm.
based modeling techniques
Hmm.
to actually generate the features for the building or the infrastructure
Hmm.
itself. Okay.
Hmm.
We need to generate the
Hmm.
attributes of the buildings,
Hmm.
which are then used for our inference later in the pipeline as well.
Hmm. Okay.
So it's a combination of both unsupervised and supervised to fill in the features such as construction year,
Hmm.
the
So it's like data
occupants,
imputation
data
too. Okay.
imputation techniques
Yeah.
using machine learning.
So this is more like filling the data gaps with machine learning.
That's right.
Okay.
And then the other step is, let's take an example of power networks, right?
Hmm.
For power networks, it's important that we actually generate the entire distribution network itself. Getting that data
Hmm.
from utility companies is almost
And
impossible.
this is because the final model is looking at damage that you might have from natural
That's
disasters
right.
to any of these things. It
Yeah.
could be to the building, it could be to the power network, it could be to any of these.
Yeah. So
Hmm.
our goal, our use cases are associated with identifying the damage to the infrastructure, such
Hmm.
as power, so that we understand the power availability and
Hmm.
how long it takes for a building to recover with respect to power back.
Okay.
Okay.
Got it. Yep.
Or
Hmm.
the damage to the building and how
Hmm.
long it takes for the building to have full functionality as
Hmm.
well.
Hmm.
And it's different for based on the occupancy type or the building use.
Hmm.
If the same building is being used for hospital, the recovery is quicker.
Hmm.
If the same building is being used for office,
Hmm.
it may have a much longer time.
Hmm.
Right?
Yeah, so the core data piece, as in the data imputation, is a core piece because if that's wrong for whatever reason or missing, then the output of the model would also be pretty poor.
Exactly.
Hmm.
Yeah.
Okay.
So for that reason, we make sure that we
Hmm.
impute these set of features in the right way. And then once that's done, actually talking about the power model as well,
Hmm.
we generate the presence of overhead or underground distribution lines,
I see. I see.
or at the
Wow.
same time also utilize network modeling to
Hmm.
generate the distribution network. But at
Hmm.
the same
Hmm.
time, we don't know where all the substations are present as well.
Hmm.
So in order to increase the coverage of substation, that's where we use visual transformers
I
in order
see.
to use that on satellite imagery and understand the presence of the substation locations. And
Okay.
then this in
So it's more
itself,
of like a object detection piece because you want to detect where the substations are and then co-locate that or identify where that is on a map so that you can then
you can
use that
then
for your
use
modeling
that
pieces.
as a part of the pipeline itself,
Okay.
right?
Mm.
And then you run the end-to-end pipeline to understand. Let's assume there's a wind event,
Mm.
what and given the impact and damage probability on each set of component in this graph network,
Mm-hmm.
how would the consequence be with respect
Mm.
to the downtime at that particular building due to power,
I see. Mm.
right? And that's basically the information which you use to
Mm.
provide business interruption scores, which is one of the metrics, or
I
resiliency
see.
scores, which
Mm.
grades locations based on the risk due to business interruption.
Mm-hmm.
Or you also have grades at a corporate level. So you now
Ah.
understand how much would McDonald's be
Mm.
risk have with the locations
Yeah.
which they have access to in terms of physical exposure
Mm.
versus Dunkin' Donuts, for
Yep.
example,
Yep.
right?
Yeah. So yeah, that's very interesting. It's not just about the building too. It's also about the way that they're interconnected, and different
Yeah,
businesses might have them interconnected in different ways, have different dependencies
yeah,
between the different, let's say, yeah, areas. Whether it's a Dunkin' Donuts, they might be more close together than McDonald's or Starbucks, for example. You might have one on one corner versus another, so maybe the dependency is not as high because if one is down, that's okay because the other one is still there.
yeah.
So I guess that's a very important piece as well.
That's right. I
Hmm.
mean, from the 2020 COVID, we are aware
Hmm.
of the impacts of supply chain disruption
Hmm.
and how it can impact the profit and loss of a company as well.
Right.
So it's important to understand the impacts of increasing
Hmm.
natural disasters
Hmm.
and see how disruption on various set of infrastructure lifelines like power,
Hmm.
transportation, or your supply chain as
Hmm.
well will have on your business itself.
But getting that data must be pretty difficult, I'm guessing,
Yeah, I
because
mean,
that data is private in many ways. So how do you try to acquire that data?
so we work with our clients
Mm,
to make sure that they are able to provide us the locations in itself,
mm,
or we work with vendors as well. Like for
mm,
example, the locations of a public company,
mm,
we work with vendors to get those
mm,
locations,
mm,
and then use our algorithms to actually understand the risk on each of these sites over
mm.
there,
Okay,
right?
I see. I see. Um, okay, that's interesting. So maybe we can also talk a little bit about talking about good AI. So we want to obviously this is doing something good, right? We understand the damage to from natural disasters. How do you see these models being used to contribute to the world? Making the world a better place in some way, shape, or form.
Yeah, I do consider we all understand the requirement of taking actions towards climate change,
Mm,
right?
mm,
We understand that the government needs to take important actions. I mean,
mm.
given the Paris Agreement and many other
Yeah,
actions which are being taken by different countries together.
yeah.
But
Yeah, a very good book on this is Speed and Scale. I think it's Speed and Scale by John Doerr. But he talks a lot about what needs to be done to actually achieve some of these goals. Because I think Paris Agreement was very broad, but there's actually tangible things you can do to make it happen
yeah,
step by step.
yeah,
But yeah, that makes
yeah.
sense.
So as we take actions towards a better world for all of us,
Mm,
there will be risks around transitioning
mm,
into a new world
mm,
where
mm,
we are less dependent on fossil fuels
mm.
and more dependent on renewable sources of energy,
Yep.
right? So that's basically reducing the scope 1, 2, and 3 emissions
Mm,
in significant ways.
mm.
And that's a goal for multiple countries and thereby also for companies as well,
Yeah.
right?
Yep.
And then you also have risks associated with impacts on your site. If
Yeah.
all the locations of a company is located in a very high risk
Mm,
region in Miami, for example,
mm.
then it's always going to get impacted by multiple hurricanes every time,
Yeah. Yeah.
right? So it's just getting disrupted. So
Mm.
it's important that uh, from the country standpoint, they want to make sure that the scope emissions that are reduced.
Mm.
And from the requirement at the company level, where disclosures are now being pushed from the government standpoint, because they want to make sure that every company is also thinking about it, there needs to be an associated financial
Mm.
activity or
Yeah.
financial incentive associated with it, right?
Yeah. And that's, I think the other side of doing good, which is actually being sustainable. And in order to be sustainable, you need to have a financial incentive, and at least in a capitalist system, to continue running as a business.
Yes, exactly.
So, yeah.
So disclosures are coming into play,
Mm.
where there is ESG metrics which are being released,
Mm.
and then there is also the climate value at risk, the f-
Ah, yeah.
the physical impact
Mm.
which is coming in to the business in itself,
Hmm.
and to the cash flow for the business,
Yep.
right?
Yep.
And that needs to be captured. That's
Mm.
where we really try to provide these metrics
Hmm.
on how the grades
Mm.
and how various assets or locations
Mm.
are getting impacted,
Ah.
and thereby at the corporate level as well, understand how the
Mm.
financial asset has an impact due to the climate change as well.
I
Okay,
see.
so
Interesting.
once
Okay.
we capture all of it, it
Mm.
creates an incentive from the investor standpoint, and thereby also a push to the company,
Mm.
which makes it a CEO's responsibility of the company
Mm.
to improve these metrics as well.
Yeah. Makes sense.
And eventually, it's a trickle down effect where
Mm.
now the companies want to be more resilient,
Yeah.
the cities will become more
Mm.
resilient.
But how does so and just want to understand this a little bit more concretely. So if you have the model, so the model is now creating a assessment of damage from different natural disasters. How does that connect to becoming more resilient, or how does that connect to uh, making the world less susceptible to climate change, for
Yeah.
example?
So we provide, think of it like X-ray, right?
Mm.
You want to understand the vulnerabilities
Mm.
in bones,
Yeah.
right?
Mm.
And where there is
Mm.
an
So you
effect on the
identify
bones.
where the problem is.
You want to identify where the problem is or
Mm.
where the vulnerabilities are present of a
Mm.
company
Mm.
based on their locations,
Mm.
and then provide a metric and a grade representing
Mm.
each and every location.
And then
Now,
what drives them to take action on this grade?
so when you understand there are vulnerabilities present,
Mm.
an easiest way to avoid
Mm.
vulnerability now is to purchase insurance,
Ah, okay.
right?
Okay.
And you
Makes
reduce the
sense.
business interruption on high
Mm.
risk regions.
Mm. Okay.
And this next step is, okay, your premiums are too high, you keep on giving the the money to the insurance companies,
Yep.
and that's where you actually think about mitigation actions. Let me just have power backup at these sites,
I see. I see.
right? Or
So
if
there's a
there is,
financial incentive in some ways. And then to your point, there's also this aspect of disclosure, which is more driven by policy or by the government, or by central agencies that say that you must disclose your risk.
yeah,
Um, so all of these kind of confluence says that in order to make a difference, in order to address climate change, uh, I need to be aware of what the problems are. And if I'm aware of all the problems through the X-ray, which is what your models are ultimately providing, then that would drive them toward action, the right action, as opposed to the wrong action. So maybe today people are taking action, but they're taking action in a way that is maybe not directed at the right problem, right? So maybe they're not aware of where the actual vulnerability is.
yeah. So we call this as precision mitigation,
Oh, okay,
where
okay,
you
okay.
know precisely
Mm,
which locations you want to mitigate the risks for,
okay.
right? And if you
So
understand
can you
the
give like an example of maybe what's done today versus, let's say, with your models, what precision could you provide to, let's say, McDonald's or one
yeah,
of these
let's
companies?
assume there exists an example around like the Dunkin' Donuts having all the locations in
Okay,
Miami,
okay.
and
Mm,
they have a budget of about $2 million, which
mm,
they have to use in order to
mm,
improve the resiliency of all these locations.
mm, So it's
Now,
it's a constraint problem.
yeah, it's a constraint problem.
Yeah.
Now, when an operator thinks about this problem,
Mm,
they may either think from the perspective of cash flow on
mm,
which locations are really giving the best
mm,
cash flow, or just look at the high risk regions from flood risk point of view and then
mm.
just put it right,
Yeah.
or hurricane point of view.
Yeah. Yeah.
But what we really want to provide over here is the business interruption risk itself,
Mm,
and then you know how much you want to invest considering various planning horizon values,
mm.
and you can have
So
a
let's say so
better
10 years versus 20
10
years
years, 20
versus
years, 30
whatever it
years.
is. Yeah.
But I mean, from the perspective of Dunkin' Donuts, let's just assume 5 years, right?
Okay. Sure. Yeah. Mm.
Um, you now understand on what the ROI would be as well because
Ah.
you capture the BI metrics,
Mm.
right? The business
Mm.
interruption or the
Mm.
downtime itself. Now, this gives enough incentive for discussing with their finance team as well on
Mm.
how effectively are they actually utilizing the budget which has
The
been
$2 million,
allocated.
dollars, right? Okay.
Yeah, so
That
that's
makes sense.
basically what we call as precision mitigation because you
Mm.
know which locations are the right ones to mitigate the
I
risk
see.
for.
Okay. Whereas maybe today it would say, okay, 2 million, let's distribute it equally because we're not
Exactly.
sure where the problem is.
That's right.
Okay, that makes sense. Or maybe they generally know that, okay, Miami region or like generally areas that are hurricane prone, but there's so many Dunkin' Donuts in that area. So like which ones are the most error prone, right? You only have $2 million.
Yeah.
So, okay, that makes sense. No, this is an interesting. So, there's good AI, right? This is obviously doing something positive. Do you see some risks with this technology? Where are some of the risks, and are they technical risks? Are they business risks? What are some of the risks that you see?
Yeah, I mean, I think as we work with more and more clients, we'll
Mm,
get to learn a lot more.
mm,
But at the same time, I think with any technology, there can be a good set of views which we are really trying to focus on over here.
mm,
We want to make sure that disasters can eventually be less disastrous
mm, mm.
to the economy, to the livelihood of everyone.
Yeah.
Uh, but at the same time, you also have an understanding of vulnerabilities which are present in the
Mm,
ecosystem today,
yep.
right?
Yep.
We do not want to have this information go in the
Mm,
wrong hands as well.
mm, yeah. That makes sense. Um, yeah, and I think it's interesting because like people have been talking a lot about language models. They've been talking about all the different potentially bad use cases that people could have. Um, my thought is that every technology can be used for bad. Computers are used for bad things. The internet is used for bad things. Pretty much everything you can think of, including our phones, right, are used for bad things. So the question is, it's perhaps a matter of time, but there's also a second thing, which is mitigation, right? To your point of even how your customers are mitigating the risk of climate disasters, you would say that if there's a risk of technology being put in the wrong hands, then there should also be some mitigation or maybe security protocols where you can provide certain ways or certain guardrails around. Like for example, we've heard a lot about this with the diversity of data sets in machine learning models, either search models or anything else. Where do we have the right data? Are we representing everybody equally? Because if there's bias in these models, then naturally there's going to be bias in the outputs that they provide. Um, so I think mitigation methods are possible. Curious if you have any thoughts on that, either for the models that you're building for climate assessments, or if you have an idea on that for the general ML space.
Yeah, I mean, I think my philosophy is basically that technical advancements are required, and for the short-term benefits
Mm,
which our
mm,
economy and the society will gain out of the
mm,
technology,
mm,
rather than fearing for the long-term
mm. So it's like
fear or
opportunism, opportunity based instead of fear based.
exactly.
Yeah.
But it's important to keep
Mm,
that in mind.
mm,
Long-term consequences are very important,
mm.
and that's where I think the government should actually step in as well
Yep.
to bring in the necessary set of policies to make sure the models are being used in the right way,
Mm-hmm.
right? And this
Yep.
has been done in the past in various sectors.
Yeah.
You do that in internet,
Mm.
and you
Yeah.
do that in every
Mm.
way of technology, the way how new technology comes in.
Yeah.
You understand the benefits of it, you
Yeah.
take advantage of it,
Mm.
but at the same time make sure that you set rules around how a technology should also be used.
Yeah. Yeah, so
It's
setting some policy guidelines or some way, and people have been talking about this AI reform or AI, um,
AI acts.
yeah,
Yeah,
AI
I
acts
think Europe
exactly.
is really pushing forward on this
Yeah,
at this point.
yeah, and there's
Yeah,
obviously some ups and downs of that, and but I think you need to have some level of government, and many people, including Mark Zuckerberg and Satya Nadella, like all of these big tech company CEOs, also have been mentioning that this is a very important thing to be at the forefront of. You want to actually have AI regulation. Nobody's saying you shouldn't have it. The question is, does AI regulation help? Is it again kind of like big pharma or like, big oil and gas, where the people who lobby the most, like big tech, or basically get the benefits, and then all the small players, one concern or any other startup, basically gets the short end of the stick because you might not be as well protected as the big tech companies. For example, if you say something like, you need to have certain diversity of data in order to ever release your models. Well, who can provide good diversity of data? Let's take healthcare, for example. Healthcare, it's so hard to get good diversity of data because of where the scarcity of data. So how can you find
yeah,
that,
but
right?
I think regardless of it being a large or a small company, it's important based on the use cases that
That's true.
we
Yeah.
keep and the right set of practices for the
Mm,
data sets and for the model development,
mm,
and only then it can actually be released for general use, right?
yeah. Yeah. Yeah.
Um,
That's a good point, and I
yeah.
think that's actually a really good point, because what you're saying is that the AI um, acts that we're talking about should be focused on really the process by which people create, like, creating guidelines around processes for how people create AI models, as opposed to saying, it needs to be this way, because there's definitely a lot of nuances. Like even in the healthcare space, there's a lot of
No, I
ways.
don't necessarily think it's just a process. It's also the performance of the model as well.
Okay, that's fair.
Okay,
Yeah, that's
so
fair. Yeah.
it's you cannot necessarily just take a current
But
existing.
performance can be gamed, right? I mean, look at all the, like, there's so many papers out there that game their, not, I mean, don't want to say game, but in some sense they do, right? Because you basically have a limited data set. Even your evaluation data set may not be broad enough. So how do you address that, right? How do you make sure that your evaluation metrics are also broad enough, but then do it in a way where the only people that can do that shouldn't be Google and Facebook. It should be like other
Yeah,
people as
yeah,
well, right?
agreed. So I think let's just take an example, right? Like
Yeah.
high stake example, like
Mm,
medicine,
yeah.
right?
Mm,
Google released the PalmMed
yeah.
model,
Yeah. Yeah.
and the ideal next step is just utilize that in the electronic health records, right?
Of course. Yeah. Yeah.
Yes, you want to just automate and
Mm,
you remove the requirement of any doctor writing any notes,
mm, yeah.
but you cannot really do that.
Yeah.
There is a limitation on the model's
Mm,
performance,
mm,
and you need to consider that in the use case development as well,
yeah.
right?
Yeah. Yeah.
Yes, it just because it answers all the questions in the
Mm,
license
yeah.
medical license
USMLE test or
examinations,
whatever. Yeah.
MLEs, doesn't really
Mm.
mean that it can actually replace the doctor's job,
Yeah. And the
right?
irony is that, yeah, and it's funny because, like, of course, that's if you look at it just from a surface, that is kind of how doctors are trained, right? You basically say, okay, you do well on your MLE test, therefore you're a good doctor, but
But
that's
it's
actually
all
not the
just
case.
beyond that. That's why
Way
there
beyond
is
that. Yeah, there's so much
a
more
lot of training involved.
deductive reasoning. There's a lot of like
But
learning from just doing, right? Like you
yeah,
basically learn by observing and all these things. Like it's just
yeah,
like a child learning. A
yeah,
child doesn't learn just from looking at images. You
yeah.
do a lot more.
So at the end of it, I think it's based on the use cases.
Mm,
That for every vertical and every use case,
yeah.
there needs to be government coming in
Mm, mm,
and connecting if the performance of the model
mm.
is actually right for the use case in
Right.
itself. For self-driving car,
Yeah.
can the self-driving car be actually be
And that's a
running
great example. Yeah.
on the streets of San Francisco,
Yeah.
right?
Yeah, so that's a good, and then see, the good thing is that at least for places like that, I'll give an example of the FDA as well, right? So for
Yeah,
software as a medical device, we have a process for the FDA to look over software devices that are going to be used in clinical settings. And the FDA will go through that process and has some process. Now, they're still learning how to do that well for AI models. That's okay. It's
yeah,
a learning process, but the same thing is happening, I think, for the what is it, the Transportation Authority, FT, I forgot what it's called, but basically the people um, who manage cars on the road and ensure that they're safe. And so now we have to think about, okay, if there's a self-driving car, one without a driver, how do you make sure they're safe? And maybe those evaluations are similar to a human in some ways, and maybe different in many ways. So the question is, how do you, at least you, in those cases, you have some level of oversight already. But not every case has that, right? So, like, for example, chatbots, like nobody said we should have, we don't have really a board or some sort of like, organization that manages chatbots. So how do we do that?
Yeah, I mean, I think it's important to start with stakes set of tasks. I mean, if a chatbot is being used for a therapy purpose, then I would still say
Right.
it requires the right set of checks and balances happening in terms of the use case and the model's
Yeah.
performance, right?
Yeah. That's a good point. Yeah. And I think it's all about, you're right. So basically, it's all about the use case. What use case is it being used for? That kind of determines the level of oversight you want, and that determines, of course, that oversight should, to some degree, and it's, I feel like it's not just government. I think government is one way. There's
Yeah,
also many cases where there's just central bodies in some way, right? So it's either like a band or like consortium
yeah,
of many different industry partners, or that also could be good because a consortium also helps because you're like-minded people, whereas you don't have these hilarious sort of weird uh, interview or panels where you have like a tech person like when Mark Zuckerberg was giving his speech to Congress, these like awkward pauses where they were asking very weird questions and Mark was giving really snarky answers. That's good in some ways, right? Obviously you need that friction, but it's much easier when you have tech people talking to each other, or even government to government talking to each other, right? And getting kind of themselves aligned first, because I think even in the AI space we're not all aligned on necessarily what the right
that's true.
approach is.
Yeah.
So it makes no sense to really try to push that battle right now when we first need to get aligned. So consortiums can also help.
Yeah, I mean, I think
Mm.
it is a very divided position of
Mm.
everyone at this point,
Yeah.
at least from the perspective of foundational models today.
Yeah.
Someone considers we are close on having consciousness in the models
Yeah.
today, and then some completely disagree.
Yep. Yep.
Regardless of us, when we reach AGI,
Mm.
it's great that we are getting the benefits of the technology and the models which are being developed today,
Mm-hmm, mm-hmm.
and also the builders to actually utilize these set of new developments of technology and algorithms to build better products.
Yeah. Yeah. And I think that aspect is, yeah, a hard one to come up with, right? Because how do you align people when fundamentally people disagree even on some of these aspects? Like, have we achieved consciousness? Have we not? And I think probabilistic models has that sort of uncertainty in some ways by nature, which is good in some ways, right? That's what provides it and makes it very human like. At the same time, it's also the very thing that makes it hard for us to agree on whether it's truly conscious or not. Because in some cases, it looks very conscious, right? It can feel like it. But then if you look at just what is happening under the hood, okay, it's a bunch of attention maps. Well, you can actually assign a probability to attention for different, words in the context size. How do so how do you account for the fact that it feels just like math? Because you can't do that with our own neurons. We can't identify that probability. So
Yeah,
I don't know.
yeah,
Um, yeah, so I think we talked a lot about a lot of awesome topics on general machine learning, also what the work that you're doing. Uh, yeah, and I think we talked a little bit about some of the challenges. We talked about bad actors. We talked about how can we perhaps prevent some of these. I thought one thing we could do is um, maybe we always like doing this in our podcast where we want the guests to provide some advice to the listeners. Now, listeners might be somebody who's looking to make a positive change with AI. They could be an AI researcher. They could be, somebody looking to found a company in the AI space, but want to do something that's going to be mission driven. Or they could be somebody that just wants to work at a company that's mission driven. So, if you were to give some advice, maybe just to give a more concrete question, what would you wish to have known maybe just a few years before? And what would you tell yourself maybe 10 years ago or 5 years ago that you now know that you wish you had known?
Sure. So I think to give a practical advice over here, it's so difficult to actually predict how the model would evolve in the
Mm.
next 5 6 years in itself.
Mm.
We could have never imagined in 2015 or 2016
Mm-hmm.
that we would be in a state today where the algorithms can be used in order to help you write code, right?
Yeah.
We just imagined on even writing a additional line of sentence based on the context from the previous sentence
Mm-hmm.
was itself a enough set of problems which are being solved with LSTMs and RNNs,
Yeah.
right?
Yeah.
So
And they were not very good.
exactly, and
Yeah.
they were not at all good. And then
Definitely didn't feel like they were conscious.
exactly. So we don't know how the next 6 years would really evolve. We can only have a better understanding of the next 1 or 2 years.
Mm. Mm.
Um, it's great to build set of new models
Mm.
around the new technologies which are coming out,
Mm.
connected with the use cases as well. It's just very essential you understand the customer and the user who would finally use these models to finally make realizable gains out of these technologies as well,
Mm.
rather than thinking about what will happen in the next 6 years and then trying to solve a problem to resolve that issue right now, because it
Mm.
will most likely not be the problem which you are
So it's
thinking
like
of it right now.
looking at the short term to really solve a problem that's, a today problem, and then once you solve that, kind of look a little bit further, as opposed to looking too much into the future without looking at what's happening today.
Yeah, I mean the algorithms would be completely different.
Yeah.
Maybe 6 7 years
Mm.
later, right?
Yeah.
The solution
Mm.
with the anticipated problem you may be solving right now
Mm.
may not be the right solution 5 6 years later.
Mm. Yeah.
You'll have to revisit the solution again.
Mm.
It's good to think about it
Mm.
and think about the challenges which comes along with it,
Mm.
but it's also important to solve the set of problems which you currently have to gain or have the
Mm.
realizable gains very
Mm.
soon.
Yeah. Yeah. So it's like customer problems first, identify them, and then solve that problem that people are having today.
Yeah, and
Yeah.
then also develop for the improved set of models for the
Of course.
next
Yeah.
four
Because
five years to
you
come.
can always iterate the models. The models can be iterated on, at least the architectures and the
Yeah,
way you build it.
you
But if it
can
doesn't solve a
improve from
problem,
various techniques,
yeah.
improve the architecture of the model, better engineering,
Mm. Mm.
better set of hardware, different set of stacks
Mm.
along the entire machine learning uh, cycle in itself, right?
Yeah.
Workflow cycle.
Yep.
But yes, I mean, it's also important to gain the advantages of
Mm.
the current technologies as well.
Yeah. That makes sense. Um, and maybe one more question I'll ask. That's great. So if in terms of opportunities, so we talked a little bit about the risks, but what opportunities do you see for either the technology that you're doing at One Concern, right, around assessing climate risks, um, to maybe in the next few years that have not yet been realized? What are the things that still can be done to improve the impact?
I think the biggest problem I feel which is not being solved in the space of
Mm.
uh, climate change is to understand the risks from climate
Mm.
across the globe.
So you mean like over time, how climate is changing? You mean from like a more wider view, like 50-year, 100-year period, or do you mean something different?
Let's consider even like 10
Mm.
years later or 5 years later,
Okay.
right?
Mm.
Or even like by 2050,
Mm.
what are the risks really coming in for us? What holds the biggest risk for the society and the whole community?
Mm.
We have different set of political issues right now which
Mm.
are creating refugees coming from various countries over there.
Right.
There may be a time where we have climate refugees as well.
Yeah. Because of the risk of climate
The
change in certain
risk of
areas.
climate change in
Maybe some
itself.
places will be underwater, some places will be burning because they're too hot. Yeah, so
right?
there's a lot of risks. Yep.
So what is the government really doing in regards to that?
Hmm.
We don't have an answer for it because we
Hmm.
don't know where it would be,
Yeah.
right?
Yeah. True. And
So
if people
that
don't know where it
new
is, they
set
can't
of
do anything about it.
community which would be coming in, which may as well just be within the US,
Hmm.
where people may want to move away from a high risk region to a
Hmm.
low risk region
Hmm.
because they cannot really sustain their lives in the normal day to
Hmm.
day
Hmm.
working, right?
Yeah.
So considering that huge set of changes which will be
Hmm.
coming in the future,
Yeah.
it's important to understand today
Hmm.
from various set of standpoint on how that risk can be captured or understood
Yeah.
so that we can take the right set of steps so that the livelihoods of
Hmm.
people at that point
Yeah.
within the US and also across the globe have been taken care of so that we don't expect to see any climate refugees and
Hmm.
there is lesser and lesser delocation of humanity from one
Yeah.
place to the other.
Yeah, and displacement is always a challenge, right? Because that's going to mean that resources need to be reallocated. So there's one thing to say, do we have enough resources for the people on the planet? But really, the biggest problem we have today is actually an allocation of resources. Theoretically, we have enough resources to feed everybody or help everybody. They just don't get allocated to the right places.
Yeah,
So,
yeah.
yeah.
Imagine like a huge percentage of population moving to a different location now because of climate impacts.
Yeah, like a wildfire risk or, whatever.
Hurricanes
Hurricanes, yeah.
being more and more frequent now,
Mm.
right?
Mm.
What does it mean?
Yeah. And nobody wants to have to rebuild their home every couple years. So, yeah.
Yeah. So
Yeah.
I think that's one of the biggest problems we have in society, as in my
Mm.
opinion, which
Mm.
needs to be addressed through the advancement in AI, through
Mm.
policies as well,
Mm.
through commercial entities as well.
Mm.
But it starts with understanding the risk
Yeah.
numerically.
Yep. Yep. Yeah. And machine learning can be a huge, huge benefit there
Yeah.
because it's really about processing the data and about probabilistic modeling.
Yeah.
Yeah. Cool. Well, yeah. Thanks again for being on the podcast. I really
Yeah, of course.
appreciate it. And yeah, thanks again.
Yeah. Glad to be here. Yeah.